Hey folks, Nathan here. It's been about 3 months since the Hydron project finished up. That was all really good fun, and there's the whole series you can watch on that. But I mentioned at the end that the next phase was to build what I called the Aquarion rocket, and the goal of this was to have double the fuel capacity, build advanced electronics and whatnot, and eventually build our way up to an actual rocket that is much more advanced than just the simple Hydron one was. So, after quite a few failed attempts and a bit of work, we finally got the fuselage for our Aquarion rocket finished. And here it is here. So right now it's just the frame. We've got the 3 bottles spliced together, and we have our 3 fins attached. And yeah, we'll discuss a bit on how that was done. So already it's been a pretty big learning curve with building the Aquarion. The splicing bottles together was a lot more difficult than I expected it to be. I thought I could just go grab some kind of adhesive, glue them together, and then it'll be good to go. But I didn't realize just how much pressure there is inside the bottle, and so my first result ended in... Okay, so the joint failed at about 20 psi, if that, so we definitely need to go back to the drawing board on this bottom part of the rocket. This is the part that we consistently have trouble with. Not quite sure what we can do to make it even better, but we'll see how we go, I guess. So that one was just using regular liquid nails. It worked up until about 15 psi, and then the entire thing just exploded. My first attempt, I didn't test this out before going out to the launch pad. So we put it on the launch pad, we started pressurizing, and then it all just exploded. So that was fun, especially when you're quite close to it, so I won't be doing that again. Next up was trying to do it again, because I wasn't sure if it was a problem with the liquid nails itself, or if it was just a problem with my actual building of it. So I tried it again. This time, instead of taking it out to the launch area and doing it, I used our greenhouse. So we had this small little greenhouse in the back, which at that point wasn't being used. So I put the rocket in the greenhouse, put me on the other side of the door, and... once again, it exploded. So at this point, it was pretty clear that liquid nails wasn't the way to go. It just wasn't strong enough to deal with the pressures that were sitting inside this bottle. So shout out to some folks. Thank you to Air Command Rockets for pointing me in the right direction. Ended up going with an epoxy instead of just a regular liquid nails thing. So the one that I used was the Gorilla Glue epoxy. It has a grip force of 252 kilograms per square meter, which to PSI is almost 3600 PSI. And since the rocket itself is only ever going to get to about 50 PSI because of the launch system that we've got at the moment, it was pretty clear that the glue would more than likely outlast even the bottles. So we got some new bottles, we cut them up, and we epoxied them up. So this one definitely went better. We put it in the greenhouse again and we tested it. But what happened was, once it got to about 30 PSI or so, it just wouldn't go up in pressure anymore. It was really odd because there wasn't any leaks, like water wouldn't leak out of it or anything like that. It's like we completely filled it with water, nothing was coming out. So wondering what's going on with this thing. And it turns out that there was a very, very slight leak in the epoxy. At lower pressures, it just wouldn't leak at all. But once you hit 30 psi, either the bottle expanded slightly or the epoxy did something or other. But yeah, at 30 psi, a very small leak happened, and you could hear air rushing out of it that wasn't happening at any lower psi, so it made it really hard to diagnose the issue. On the plus side, the fact that the bottles just leaked instead of exploding was a pretty good sign that the epoxy was strong enough to actually hold everything together, and that in this case it was an issue of gluing technique and not the epoxy itself. But eventually we figured that out, tried to epoxy over it just to see if that would work, and it didn't. So once again we had to scrap that, grab 3 new bottles again, cut them up, and build a new airframe. And so this is where we are now. The new capacity is around 4.3 to 4.4 litres, so that fulfills our requirement of being at least double the previous one. So you'll notice with this that some of the inside is blue. The reason for this is that in order to test it out, just that it would actually hold water, I filled it up with water and put blue dye in there, and then when I pressurized it, see where basically any leaks or anything would be. And yeah, fortunately we didn't find any with this one. But now as a result of that, some of it is just permanently stained blue, it seems. So it gives a nice bit of character to the rocket, I find. Next up is to actually do some testing on it and see how it flies. I need to just put in something to ensure that it will survive the landing. I'm not sure if I want to bother with a full parachute system, so I'm going to be testing out just a simple crash system for it. And testing and evaluating that crash system will be the topic of my next video. So, Aquarion Phase 1 is complete. We have our airframe, which is fully sealed, a much larger capacity, and in theory should work quite well. So, that's it for this video. Catch you later.